Welcome to the 25th part of our interview series. Stephen, you've discussed various types of directional fractal antennas. Can you explain which of these could be configured to work in a phased array for enhanced directionality and how that would work?
Certainly, Joanna. Configuring fractal antennas into a phased array can significantly improve directionality by allowing precise control over the phase and amplitude of the signals fed to each antenna element. Ruth and Brian can elaborate on the specific types of fractal antennas suitable for phased arrays and how they can be configured.
Ruth and Brian, can you break down the types of fractal antennas that can achieve enhanced directionality when configured in a phased array?
Absolutely. Here are some fractal antennas suitable for phased arrays. Fractal Yagi-Yuta antennas. Configuration: multiple fractal Yagi-Yuta antennas can be arranged in a phased array, with each antenna element fed with a slight time delay relative to its neighbors. This creates constructive interference in the desired direction, enhancing directionality. Advantages: this configuration benefits from the inherent directivity of Yagi-Yuta antennas combined with the flexibility of phased array steering. Spiral fractal antennas. Configuration: spiral fractal antennas can be arranged in a circular or square grid to form a phased array. By adjusting the phase relationship between the antennas, the main beam can be steered to different angles, providing greater control over the directionality. Advantages: spiral fractal antennas offer broad bandwidth and can be designed for various polarization options, adding versatility to the phased array. Fractal planar inverted F antennas, PIFA. Configuration: multiple PIFA antennas can be positioned in a linear or planar arrangement to form a phased array. Adjusting the phase between the antennas allows for beam steering and side lobe reduction, leading to improved directionality. Advantages: PIFA antennas are compact and can be integrated into planar arrays, making them suitable for applications with space constraints.
What considerations are important when designing directional fractal antennas for phased arrays?
When designing directional fractal antennas for phased arrays, several key considerations must be addressed. Controller module or RF switch. Phase shifting. A controller module or RF switch is needed to handle the phase shifting and signal distribution among the antenna elements. Signal synchronization. Ensuring precise synchronization of signals to achieve the desired beam steering and directionality. Array layout and spacing. Optimal spacing. Determining the optimal spacing between antenna elements to avoid grating lobes and achieve efficient beamforming. Array geometry. Selecting the appropriate array geometry, linear, circular, or planar, based on the application and space constraints. Complexity and cost. Increased complexity. The complexity of the system increases with the number of antenna elements, and the sophistication of the control mechanisms. Cost considerations. Balancing performance improvements with the cost of additional components and manufacturing.
To further understand the technical aspects and challenges of configuring fractal antennas into a phased array, we consulted an expert in antenna design and phased array systems. Ruth, can you summarize the expert's insights?
Configuring fractal antennas into a phased array for enhanced directionality is a feasible approach. Fractal Yagi-Yuta, spiral fractal, and fractal PIFA antennas are well suited for phased array configurations. However, careful design, precise control of phase shifting, and optimal array layout are essential to achieving the desired performance. The complexity and cost of the system should also be considered to ensure a practical and efficient solution.
Stephen, your detailed understanding of configuring fractal antennas for phased arrays is impressive. How do you plan to address the challenges and ensure the effective implementation of such a system?
Addressing these challenges requires meticulous planning and precise design. I plan to prioritize achieving optimal performance by carefully selecting the array geometry and ensuring precise phase control. Balancing complexity and cost will also be crucial to implementing an efficient and practical phased array system.
Your commitment to understanding and applying advanced antenna design principles is commendable. Sharing your insights and strategies not only helps you but also provides valuable guidance to others interested in exploring similar technologies.
In this 25th part of our series, we've explored the potential for configuring fractal antennas into a phased array for enhanced directionality and the design considerations involved. Stay tuned for the next part, where we will continue to explore potential defensive strategies and support systems for those affected by similar forms of harassment.
Stephen's story continues to highlight the relentless nature of technological harassment and the sophisticated strategies required to combat it. By continuing this series, we aim to provide a comprehensive understanding and foster a dialogue that can lead to meaningful change.